Okay, so we're going to be doing graphing trig functions, and we're going to start with a sine curve. Now, if you remember from the previous unit, sine we connect with our y values, right? Okay, so let's just kind of look at the way we would start this. So over here, we have a unit circle, also from last unit. And so we've got 0 degrees, 90, 180, 270, and you remember all these coordinates. So if sine are your y values, then basically what we're going to be focusing in today is on, for 0 and 360, a y value of 0, 1, 0, and negative 1. Okay, so this is the way that this is going to work. What we're going to do is we're going to start on the x-axis, and the x-axis are going to be represented by all of the angle measures on the unit circle. So the 0 and 360, the 90, the 180, and the 270. However, when we do that, we put them in radian measure. We write them in radian measures. So, like for example, remember, if you have 90 degrees, we can multiply that by pi over 180, and then when we simplify that, that's pi over 2. So what you're going to do is you're going to start at the origin here, and we're going to go out 2 spaces. You're going to put a little slash, and we're going to write pi over 2. So the origin is obviously represented by 0, and then if we start here at 0 and we rotate 90 degrees counterclockwise, we go to 90, and there's 90 degrees. But in radian measure, it's pi over 2. So then what we're going to do now is we're going to rotate another 90 degrees. So we just went from 0 to 90. Now we're going to rotate again another 90 degrees in the counterclockwise direction, which is going to bring us to 180 degrees. Now again, we don't want that in degree mode, so we are going to take, 180. We're going to multiply that by pi over 180. You can see the 180s will cancel out. So 180 degrees, its radian equivalent is pi. So we're going to put that there. Okay, now what we're going to do is we're going to continue to go 90 degrees in a counterclockwise direction. So that's going to bring us to 270. And again, we're going to want to change 270 to radian measure. Now I'm not going to show you that one, but we're going to take 270 and we're going to multiply it by pi over 180 and reduce it, just like we did with the last one. So you can stop me for a minute and you can work that out and see what you end up getting. Okay, so you should have ended up with 3 pi over 2 for 270 degrees. And then if we rotate again another 90 degrees from 270 all the way around counterclockwise, we'll end up at 360. And you can do the same thing, figure out the radian equivalent to that. And that ends up being 2 pi. Okay, so basically what we did is we took one little circle around our unit circle, 360 degrees, and we have these angle measures: 0, pi over 2, which is 90, pi, which is 180, 270, which is 3 pi over 2, and 2 pi, which is 360. Okay, now let's go back to the y values here. Our lowest y value of these 4 is at -1. And do you see our highest y value is a +1? So what that means is on the y-axis, I know that I have to go up to 1 and down to -1. So what I like to do is spread it out a little bit so it looks a little prettier. So I'm going to actually skip 4 boxes, and I'm going to put a slash, and that's going to represent a height of 1. And then I'm going to do the same thing in the negative direction. So I'm going to skip 4 boxes, and that's -1. Okay, well, at this point, it's actually pretty easy. So we're going to start with 0 degrees. So let's go to 0 degrees. We're right here. And we look for its y value, right? Because sine corresponds with y value. And we see that it's 0. So then what that means is we're going to go to 0 degrees. And at 0, it has a y value of 0. So we just put a dot there. There's our first point. Okay, let's go to 90 degrees. So we go over to 90 degrees. Its y value is 1. So at 90 degrees, the sine of 90 is 1. So I'm going to go to 90 degrees, sine, its y value is 1. And we go to 180 degrees. Its y value is 0. So in other words, the sine of 180 is 0. So let's go to the sine, let's go to 180 rather, and we're going to put a dot at 0. We're going to do the same thing again for 270. Here's 270. Go to its y value. Its y value is -1. So that means the sine of 270 is -1. So I'm going to find 270, and I'm going down to -1. Okay, last one. We're going to go to 2 pi, which is 360, right? 2 pi is over here. Its y value is 0. So the sine of 360 is 0. So I'm going to plot 0. All right, well, so those are the points that we need to graph our sine curve. Now, this is a curve. It's not supposed to look pointy in any way whatsoever. So look at me draw it, and then all of this you should be writing in your notes. So it's going to go up like this, and then it's going to go down like this. Okay, so there is your sine curve, which starts at 0, ends at 2 pi. And notice what happens. Okay, so let's take a look at what we call the behavior of the sine curve. If we're going from 0 to 2 pi, 0 to 360, notice that we start at 0, we end at 0, and in the middle of our graph, we're also at 0. So we have 1, 2, 3 zeros. Then look at what happens between these two zeros here. In the middle, we go up to its maximum. And then between the second two zeros, in the middle, we go down to its minimum. That's the behavior of a sine curve. We start, end, and in the middle, we're on the x-axis. And then in the middle of each of the two zeros, the first two, we go up to its maximum. The second two, we go down to its minimum. Okay, now that's going to change a little bit, but for now, that's the behavior of the graph, and we kind of want you to get familiar with that as soon as you can. Okay, now, this is kind of like a wave, and you know how a wave goes up and then it comes down. So this wave, so to speak, can continue. We just went from 0 to 2 pi, but we could continue over here as well, and we could actually continue off this graph. We could go 2 pi, and we could go out further, and so we go up, and then we go down. Then we would go up, and then we go down. So it's just like a wave that continues forever. But we usually will have a domain, and a domain basically tells you where should you start and where should you end, which we'll get into more a little bit. But I want you to, now put this in your notes, do the same thing that we did on the right side of the y-axis, and let's repeat this on the left. Every other box, put a slash. Now, basically, we're just going to be going in the negative direction. So if going to the right two boxes from 0 is pi over 2, going to the left would be negative pi over 2. If going 4 boxes from the origin is pi, going to the right, then going to the left 4 boxes will be negative pi. Then you can imagine that this is going to be negative 3 pi over 2. And the last one is negative 2 pi. Okay, so it's kind of like a reflection over the y-axis if you want to think about it that way. Now, let's talk about the behavior of this curve. So remember how I said the curve starts by going up, and then it comes down and back to 0 again. So then it should, from this point, if I was going to the right, I would go up, and then back down, and then back to 0 again. Well, look at this. If we're coming from the right-hand side going toward the left, we go up, we come back down to 0. Shouldn't our graph then go down and then come back up again? Okay, so there's another way that we can look at this. If we're rotating negative 90 degrees, let's go to the unit circle. Negative 90 degrees means, and starting at 0, because our initial side, remember, always lies on the positive x-axis. If I want to rotate positive 90 degrees, I go up. If I want to rotate negative 90 degrees, I go down. So negative 90 degrees is really in the same spot as positive 270. And look at its y value. It's at negative 1. So that means at negative pi over 2, I'm going to put a dot at negative 1. Let me make that red so it matches the other ones. There we go. Okay, next we're going to go to negative 180. So again, let's start at the initial side, which is the positive x-axis, and we're rotating down 180 degrees because it's negative. So here's negative 90, here's negative 180, and its y value is 0. So we're going to have a dot right there. All right, let's go to the next one. The next one is negative 270. So again, I'm starting on the positive x-axis. I'm rotating negative 90, negative 180, negative 270, and its y value is 1. So at negative 270, I should be up at 1. And lastly, negative 2 pi, I'm starting here at 0 degrees, and I'm going around negative 360, which lands me right where I started, right? And its y value is 0. So I'll have a dot right there. So if I connect these, this is what the graph will look like. Okay, so this is your sine curve. All right. All right, so next we're going to do the cosine curve. Now this is going to be very similar to the sine curve, except that, if you recall, cosine corresponds with your x values. So we're going to use this same unit circle up here, but we're going to look at the x values. So this is going to go a little bit quicker because we kind of have a little bit background knowledge here. So every other box, you should be taking notes in your packet. And remember, we're going to go pi over 2, pi, 3 pi over 2, and 2 pi. We're going to do the same thing on the left-hand side of the y-axis. So I've got negative 2 pi, negative 3 pi over 2, negative pi, and negative pi over 2. Okay, it's the same unit circle, so our maximum is going to be at positive 1, and our minimum is going to be at negative 1. So I'm going to go up 4 boxes and put a 1, and I'm going to go down 4 boxes and put a negative 1. All right, so here we go. So just be careful because the only difference here is we're going to be plotting x values instead. So if I'm starting at 0, let's start here at 0 degrees. The x value at 0 is 1. So that means the cosine of 0 is 1. So the cosine of 0 is 1, so that would go right up here. All right, the next value that we have, remember, would be 90 degrees. Its its x value is 0, so the cosine of 90 is 0. So I'm going to go to 90 degrees and plot its height, which is 0. All right, go to 180. 180, the cosine of 180 is negative 1. And it's negative 1 because cosine corresponds with its x value. So 180, which is pi, is down at negative 1. And we keep going. So the next one is 270, which is 3 pi over 2. Its x value is 0. And lastly, you can look at 2 pi. You see that its x value is 1. Okay, so this one's a little bit different. It looks like it would be a V, because it's a cosine curve. We never have a V. And it's not a parabola either. So it actually looks like this. Let me draw it first so you can see it before you sketch it. Okay, so here's the thing that you need to notice about a cosine curve. See how it's got like a little outward flare at this end, and it's got an outward flare at this end. That's necessary. It can't look like a parabola. It's a cosine curve. Okay, and also remember that this curve would continue on. So if I were to keep going, it's got to come back down. And if you don't flare it, it's going to look very pointy up here. So just make sure that you have that flare. You will lose points if you don't. Okay? All right, so there's your cosine curve. Now let's compare. The cosine curve, notice the cosine curve starts at its maximum, finishes at its maximum, and it goes down to its minimum here in the middle. Different than the sine curve, right? Because the sine curve starts at 0, finishes at 0, and goes to 0 in the middle. And then in the middle of these two zeros goes to a max. In the middle of these two zeros goes to a minimum. This one's different. Max, max at the beginning and the end, minimum in the middle. Now, in the middle of this maximum and this minimum, look at what you have. You have a 0. And between this minimum and this maximum, look at what you have in the middle, a 0. Okay? All right, so then we know then if we're at a maximum here, oops, right here, if we're at a maximum of 1, we're going to be dropping down, right? So, and let's go based upon the behavior of the graph. So I know that I should begin and I should end at a maximum, and then in the middle I should go down to the minimum. See, like that. However, in between each max and each min, I have a 0, so I'm hitting the x-axis there and there. That way we can go based upon the behavior of the graph. So remember, we flare, and there's your cosine curve. Okay, so this is y equals cosine